Good evening, everyone. Welcome to Advanced Course in Drones and Development. Today, we're going to be talking about something really interesting, and that's optimization of unmanned systems. To be sharing about this topic and his personal story, we have Nishant Singh Rana from Vyorius. Nishant, welcome to the course.
Thank you so much, Dr. Ruchi. It's a pleasure to be here, and I love to share more, regarding my journey and everything. Can I go ahead and, actually share slides with you? And while doing that, I can basically talk with you all.
Yes, please.
Awesome. Just let me know, once my screen is visible to you all. Is it fine?
Yes.
Fair enough. So before I begin, I want this to be a very sort of an informal session. Uh, I was here where you are about 6 years back. So I know, the feeling of, seeing, newer things happening and being a part of it. So while I move ahead, if anyone has any question, any doubt, even a comment, feel free to do that. What I'm going to be speaking about is going to be very, very, influenced by my own experience. So nothing is factual, and this technology and the whole field is changing. So everyone, if anyone feels, against or in pro, feel free to comment, whatever you have in your mind. And I'll be really looking forward to interacting with you all. So before I go ahead, just a quick introduction myself. So I come with a BTech in engineering physics with a majors in electronics and minors in robotics and smart systems. I've been working with drones, unmanned robotics, rovers and stuff like that for about 6 years now. I have worked globally, so I'm a fellow from Royal Academy of Engineering, Bring Poland, EF Singapore, C5 and Center US. So even if you have any questions regarding the whole startup ecosystem and how robotics in itself is being catered to, or how exactly the plugs are fitting all around the globe, I love to speak about that as well. So currently, I'm basically working as the CEO and the founder of Vyorius. And with Vyorius, we had this journey of about 2 years. Initially, we started as a company, as a team, which were actually looking to amalgamate both the technologies of both a helicopter and a conventional plane together. So right after college, we were basically working on a project. The idea was that the cities are shrinking, the infrastructure is getting denser. So how we can actually make sure that the mobility that right now with the airstrips and all and airports take huge spaces. So how we can actually restrict that and minimize that. And the idea was to basically bring in the capabilities of both a helicopter and conventional plane combined, and so that we can actually take off from small piece of land and fly larger duration and things like that. And in that journey, basically, we fumbled upon sort of to the idea of why not we basically use this in a miniaturized fashion. Initially, we thought about flying people. Then we thought why not we just miniaturize it and fly payloads with that, like smaller payloads that we can actually use in civilian airspaces. And yeah, that is how our journey started. So with this slide, why me? I essentially want to talk about specifically, how robotics and how operation itself, the robotic and the robotic operation itself, kind of is very contradictory in itself. When we are going to be talking about it, I'll talk more about it. The idea of unmanned system is that you create such a system, such a cohesive workflow where you don't need humans and people to be involved with, and we can actually reduce the cost, time, as well as the manpower associated with it. So that this is something that I'll be talking more about. Getting back to my journey, so we sort of started as we pivoted from just creating these systems to rather creating a whole delivery network of these drones. So we created drones that can travel 100 kilometers, carry up about 5 kg of medical supplies. We created tech where we'll basically dispatch real-time parameters in terms of your pressure, temperature, humidity, and luckily, we were basically funded by Polish government at the time, so we had like the open hand in order to basically experiment and do these trials. And we did them in some in India, but most of them in Poland. And while we did that, we basically realized that the operations that we were running, even though we were essentially creating an unmanned robotic system and unmanned robotic workflow, most of the operations that we were actually doing, they were entailing everything that needs humans to be interacted with them. So if I'm basically planning to replace, 5 people, I'm actually adding 5 more, because there's something that basically is required, on top of that autonomous layer, to basically command it and control it, and do everything that you need to do. So the kind of operations that we ran, at the time, was that we manufactured our own drone. We ran operations with that. We were doing maintenance. We were taking care of the compliance, and then we were interacting with the client. And even though we were basically creating a autonomous fleet, we're basically doing it all involved with humans. So real people interacting with these machines and then getting the work done, which was kind of suboptimal. And that is when we realized that there are disparities that exist in robotic automation, and people aren't even talking about it. People have understood the concept of saying a technology to be at a niche and a starting stage, but this technology has been there, for tens and 20 years, hundreds even, for the military side. So US was already using drones and stuff, like 40 years back. So the technology is not in itself completely unique. What's unique is that now people have actually started integrating this technology in real world workflows, and started to utilize this technology in applications which are currently people have realized, right? And yeah, so this is something that we realize is completely broken. We If we talk about the market, as entrepreneurs, market comes very lucrative. We all wants to hear how much money, how much impact that one company or one solution or one application system can actually have. And if I give you that number, then that number is about $54 billion. And this number will, the robotics industry, specifically talking about healthcare, agriculture, and logistics, will reach there. And once they do, they'll still have these stagnant processes and workflows, because current focus of these companies, even ours, a year back, was to make sure that we can actually make these systems more efficient, make these systems more robust, make these systems more fluid, but no one knew how we are going to be integrating in the workflows. So if I go back to it and I talk about the barriers that we figured out, in unmanned robotic services, it's that the first thing is the poor end-to-end visibility. We fly a drone, we even drive a self-driving car, maybe a self-driving truck. The major differentiation that happens, is the poor end-to-end visibility part of the things. If you right now order an Uber, as a client, you will be able to see in real time precisely where your Uber is, how long it's gonna take, and like what the distance, who is basically driving that, and all the rest of the information. It's very transparent. It's real time visible. But if we take that in, let's say self-driving cars, right?
Nishant, you've gone on mute. Strange.
Yeah, am I audible now?
Yes.
I don't know what happened, but
No, just 10 seconds that we lost here.
okay, I'll go back to it.
Sure.
Right. So what I was talking about precisely was poor end-to-end visibility. So I just taking the example of how if you order an Uber, you can basically see precisely whatever is happening, where it is, how long it's gonna take. But if I specifically talk about this, if you order someone to survey your farmland, if you order someone to basically take a really amazing video via drone around your house, you as a client won't have that visibility till the point of time that person comes back to you and provide the final outcome, the final data. And that is something that is lagging. So this specific example of surveying a land or taking a video is very like minuscule, when you're going to be comparing it towards a self-driving car or a drone delivery or an air taxi, because at that time you can basically directly relate to how Uber and a self-driving car, the experience is going to be completely different for you as a client when you order them, if you don't have that complete visibility in with these robotic systems out there. Moving ahead, if we then talk about these systems and how they can actually communicate with each other. So the problem now arises that if these systems are, let's say, manufactured by a same company, DJI can communicate with DJI, open source can communicate with open source, someone else comes up with their own proprietary system. Now there needs to be a layer in which all these systems, irrespective of who is manufacturing them, what firmware there is, and what protocol system that they're using, should basically communicate with each other to reduce the accidents that can happen with the workspaces. And that is sort of the major conundrum that the industry is facing right now, because you already have a Tesla. All right, you can self-drive it, you can do all of that you want, but now if Mercedes comes up with their own self-driving system, they won't be able to communicate with each other until unless there is an overlying layer. Now there is again a problem. When we talk about an overlying layer, we are usually talking about a UTM system, and that UTM system is going to be governed by let's say a city or a nation, or the countrywide. If it's Europe, then the European Commission will be basically specifically creating these UTM providers or giving them contracts. If we drop down it a bit and we specifically talk about the fleet management or the integration that will happen when someone will have 10 Teslas and they would want to basically command them, control them, and do all of that. Now that is sort of the layer which is most needed when you basically want to share the data that Uber X, Tesla X is going to be picking Y person, and Z Tesla is going to be picking X person. And this is sort of the data feed that you want as a management system, which can act so that these systems can communicate with each other and also with others when they can be integrated with the bigger UTM, which is the countrywide UTM. Now you have all the data. The data is already started flowing. Then there's this whole process of who is going to be processing this large amount of data. Is it going to be the UTM player, who has this countrywide access? Definitely yes. But up to what extent? So what specifically that UTM player will provide you as a user that that you can actually benefit from? They can provide you, your air awareness data, either the drone, so air awareness. If you are a car, then other cars around you, self-driving cars. But if you are an enterprise client having these these multiple assets lying around, this is not the only data that you require. You require very specific, precise data in order to know how you can actually make your own operations more efficient. So if I ask you, you have 10 different Tesla cars, and now tell me which one is more efficient, because even if you have the similar car, everything similar, the efficiency is always going to be different, because it's all about hardware, right? You change, you nudge, you do a specific tweak, and everything will be completely different. Now this thing will not be a concern if these are just like 10 cars doing like 1 or 2 deliveries or pickups once in a while. But now if you scale that up, if these cars are now regularly being used and they're actually processing hundreds of transactions, then if you basically save even $1 or a penny, then you're essentially saving $100 or 100 pennies, or even let's say come down to just 100 rupees. And that 100 rupee yearly can actually create a tremendous difference in your own operations. And then thus becomes the barrier where who is going to be optimizing this data? Who is the company going to create it by themselves, or there could be someone else who do that, or they can basically just leave it to the UTM players, who whatever data that they think will be great for all the generalized user base that they have, and they provide you. So let's say we have even done that, we move forward, and then we talk about the focus. Uh, I actually have started with this. I actually have taken a bit of introduction with the audience that I'm connecting with, but maybe I'll do it afterwards. So if I had like manufacturers in the audience, if I had like operators in the audience, and I believe right now I have a lot of students in the audience, then this focus creation is basically lacking from the manufacturer's point of view, because operators are like more focused on the operations part. The manufacturers are kind of focused on how optimum or how amazing product they can build. But the problem lies that no one needs the most amazing product. The thing is, there couldn't be a single solution that fits all kind of a scenario. A drone that can actually carry 5 kg and the drone that can just carry 500 kgs will have different use cases, and they will be applicable in different scenarios. So you cannot just have a 5 kg drone carry a 500-gram thing and do the delivery and still call it, the most efficient way to do it, even though you're saving 20 minutes or 30 minutes of your time while doing that. The idea is that the manufacturer should have the complete capability of understanding the whole integration that is going to happen with the client side, which is not there. And if we talk about the operators, then currently, because there is no underlying layer that can actually support that, then even they don't have any understanding of how they can actually optimize these operations. So for now, talking about the current scenario, it's more about proving that these systems can exist, proving to the governments that these systems can work, and proving to the end clients that they can actually derive value from this. But the real value that will be derived eventually will be in terms of how economically efficient these systems can be. Because if they are not going to be economically efficient, then there will be very less use cases that will benefit the end user. And these cases definitely start with healthcare, and that is essentially why we started with healthcare as well. But if you're talking about pizza delivery, delivering your tire cars, until unless the cost is going to be minimum, you will never be seeing a pizza delivery happening with a drone at a scale. Definitely are going to be doing like Domino's is going to be doing just for the advertisement, but not at scale. The last thing is the downtime. You know, the more these robots are going to be working, the more money they will be making for you as a operator. And this is essentially what you want. So everyone, both the manufacturer's job is right now to basically make sure the how much battery they can put inside the specific system so it can move at max. And the operator side is that how much payload, how many cameras, how many things they can basically put in over that system, and in what frequency they can actually run that system altogether again and again without them to worry about when the system is going to go down. So you think these are all the different barriers that cumulatively create a very sort of a solidified case for why these you are not actually seeing these robotic adoptions happening, why countries are so reluctant in passing these regulations, and why Amazon, when they actually said that in 2012 and 13, they haven't still done a very commercial delivery, even though that's like the world's biggest company out there. Because the idea to optimize these operations back and forth, not just the drone, not just the robot, but how it's going to be integrating with the real world workflow, how every single aspect of the drone delivery or the robotic system or the robotic operation can be unmanned is sort of the basic criteria to understand how you will make it economically feasible, and will basically move ahead with that. So with what I've spoken to you, one thing comes up, and it is that there is this underlying need of a layer, and every single of these robotic company will essentially need these. I mean, I'll talk about these, but these specific tech stacks to be integrated with the robot, irrespective of the robot. It's a self-driving car, it's a drone, it's a air taxi, it's an unmanned ship, whatever it is. Every single of these robots will require these specific tech stacks to be integrated with how they are being connected with the workflow that is happening on in the backend. And with the backend, I mean how humans are interacting with these. So essentially, this creates sort of a infrastructure problem, right? We all talk about infrastructure problem, and the first thing that we think about is physical infrastructure, roads and flyovers and tracks and stuff like that. But this is not what the robotics industry need. Robotics industry is there because the physical infrastructure that you have is not appropriate. It's not sustainable. Carbon emission is so much. People want EVs, and essentially that is why this robotic adoption and the world is moving towards robotics. It's not like you don't have a alternative. You do have an alternative, but the alternative is not better than the robots in itself, right? People talk about how people will be losing jobs, but it's not like that. The jobs will be swapped, right? So currently, let's say people have a job to build a flyover. Maybe 10 years down the line, the job will basically change in order to just make sure that the drones have sort of a free flying layover or a track where they can actually fly. So the things will change. And the idea for them to change is that if there can actually be an infrastructure that can actually support these systems and actually make them truly unmanned. When I say truly unmanned, this is again a very contradicting statement. I don't think even after 7, 8, 10 years down the line, things will become truly unmanned. The idea is that these systems can be smart, but these systems cannot take decisions by themselves, and that's why you will always require humans to supervise them. AI can definitely evolve, but you will again need humans to basically make sure, or to guide AI what's specific. Essentially, the problems are always going to be funded by humans. So humans are going to be developing AIs, and the AIs are going to be automating the whole system. So before the AI comes, and when as humans we are already here, and how we can actually do this, let's say 60-70% unmanned, is based on the fact if we can actually develop each of these modules and make such that any robot out there will be able to integrate and just plug and like take service out of these modules and not rely on developing the wheel altogether again and again. I hope that I'm making sense. I'll get back to you guys and listen to you as well. The idea was that I kind of interact with you with every single slide, but because I cannot see you right now, so I'll do that afterwards. So moving from understanding the tech stack requirements of these robotic system, agnostic of what they are, we move towards how enterprises kind of understand these robots entering in their workspaces and in their workflows, and how they actually think that their people, real humans, will be able to interact with these robotic systems. Now you see, I haven't yet talked about any kind of specific robot. I haven't talked about any sort of technology or any dramatic change. It's all about how these humans can actually directly integrate, and how the data that is being processed can actually be analyzed. So if we talk about existing systems, and the kind of if we segment the way that humans are interacting, or the roles of humans that basically are interacting with these robots. So I've done some color coding for you guys. If you look at on the right side, and we start with command and control and compliance. So I think every single one of us must have heard these two terms, right? Till now, with these robots, everyone wants to own the best command and control system, the navigational stack, everything. Humans controlling these systems. And the second thing is that the compliance are so bad right now that people can actually not move ahead and do services with any of these robotic systems out there. And these have been like the two major discussions depending on these two specific terms. Now, what I mean when I say these command and control and compliance and putting them in green is that currently humans are already controlling these robots and these drones. So humans already know how to command and control, and how to interact with these systems. Humans are already taking care of the compliance right now, so that is also done. Data storage comes again as like the next part of the things, where the command and control is done. You have a pilot, you have a driver who is already doing that. Compliance is done. The CEO, the executives are basically doing the paperwork, and it's all done. Then the part is that you're basically generating the data sets. Now, how you can actually make sure that the data storage can be automated, right? But again, it's not. So humans are all there. They basically do that in micro SD cards. Bring them out once the mission is over. Put them in their desktops. Save all the files. Take the data. Put it in another software. Analyze that. Great. And once that is done, then again a different set of human as a role does the maintenance part, where they see through everything that's happening, pre-flights, post-flights, all kind of checks, and do that. So you see, every single point that I've mentioned basically already have a human involved. If we go towards the left hand side of the things, now comes the order management part, asset management part, client interaction, and remote supervision. And these are the four terminologies that doesn't appear anywhere when you actually talk about robots, robot interactions, or unmanned operations. These are the things that basically people take for granted, as it is something that will be taken care of by the executives, the companies, whoever is basically doing that. There will be some person who will be putting things in Excel, or writing things down. They'll be putting how much battery is left, or how much flights a specific system has done. Which system is ready to go, which is not. So this is all the things that are right now being done by humans, but no one cares about that. No one talks about that. And if you think at an enterprise level, if you have like one client, or you have like one drone, 10 drone, it's okay. Think about having 500 drones, and think about having how many people that you require in order to just do the command control, the compliance, the data storage, maintenance, remote supervision, client interaction, asset management, order management, humans. It's all about humans. There will be 500 robots sitting and you'll be able to see them. What an amazing fleet. But then there will be 500 odd humans just in front of them, which will actually be doing. I've kind of excessively said 500, but I just want to convey that there will be a huge number of humans that essentially will be doing those tasks. Fair enough, we can do that. I mean, there are already a lot of humans all around, so definitely we can do that. But then the problem arises that how are we going to be making sure that the systems are optimized? How are we going to be making sure that the data that these humans are taking can actually be analyzed, and there could be something, this is the thing that I've basically put in red, which I call operational analytics. Every single field you will have some analytics going on in the back end, in the background. For every single company out there, Amazon has its own analytics. How many orders they sell, in every single second, how many they do, what is sort of the prep time, what time the order actually got sent, when actually did the team received an order, how much time it took them to basically do all of that. Now, this is great for Amazon, considering Amazon is not robotics per se. E-commerce side is not a robotics company. It is not pushing itself as a cutting edge, company which is making things for unmanned systems. So it's okay. Amazon can actually hire a million people to work and to analyze the data and put it forward. But if you're actually creating a company, if you're actually working on a cutting edge solution, where the MVP and the main thing is that things are autonomous, things are automated, and then you go backwards and then you start doing everything manually, doesn't make sense and doesn't actually cut the cake, because your operations are the only thing that is going to be driving the worth, because robots essentially can cut some cost but not all the cost. The real value of having an unmanned system is that you basically cut the operational cost that could be like that was there when humans were involved, and once you remove that, you essentially make the whole process very, very efficient, right? So what I wanted to tell you is that on one side we have this undifferentiated heavy lifting. We have every single segment and every single tech stack that needs to be integrated with all these different robotic systems, which are kind of similar. And then on the other hand side, you have got enterprise operations going on, where every single role is being assigned to a human, and a human is essentially doing these jobs. So this basically creates a kind of a conundrum, how you actually going to be optimizing these operations when the lack is coming because humans are not that efficient while doing their job, right? Or if I even not say like our job itself, the job that essentially was to be done by a robot, and we took it because we didn't have the capability to optimize that or automate that, at least at this point, and then we did ourselves. So that definitely is not going to be the highest in terms of the efficiency right now. So and this is essentially how the current robotic operations are being done, right? Drone deliveries, experimentations going all around, companies developing these amazing hardware system, ourselves as well, case in point, 1 year back. And yeah, then the idea is that once we prove that, then we'll be essentially start thinking about how these systems can actually get integrated with what we are trying to do, what any other company is trying to do. And that essentially creates a problematic thing, because if we move forward toward the key progress indicator for any technology, any stack, any newer thing, any innovation, it basically lies on like 4 or 5 different things, right? It's about the safety, how safe the system is, in the application is, the whatever you are doing, how efficient your newer thing can actually make the one that was previously already done, how scalable that is. If I basically put 2 robots now, and if I add 2 more, and can I keep on going adding like 2 more until the point of time where I have like 100,000 robots all around, and will at that point I'll be like very, very optimum? Will there be any problem? Again, going back to the first slide I shared with you, the whole communication gap, and the whole visibility gap and stuff like that. And the flexibility is something that is very, very important to understand, because everyone knows safety, efficiency, scalability. Flexibility is something that is newer, and it is very, very specific to operators, right? So I said that there couldn't be a one size fits all solution. So what essentially it means that as an operator, currently you have a need, let's say for a rover, tomorrow you will have a need of a drone, The other day you'll essentially require a drone that can carry larger payloads, maybe an air taxi. So how, as an operator, you can make sure that you won't need to retrain your people again and again. How you can actually make sure that you won't have to change your workflows again and again. How you can make sure that you can actually opt for multiple manufacturers, multiple products, and you will still have that flexibility to not change everything that is happening on the back end, because you already have a company going on. There are already 100, let's say even 10 drones flying. How you can actually make that. So that is essentially what I mean by flexibility over here. And then last part is the productivity. And when I mean productivity, I don't just mean the productivity, how productive the robot is. What I mean by productivity is how the robot human interaction is, how productive that is, because that is how, because your take as an enterprise, your take as a product manager, your take as someone who is going to be leading these robotic developments or implementation is not going to be focused on how amazing a single robot is. Your focus is going to be how multiple robots, or even let's say even a single robot, how optimally that robot is basically doing these things. And you as a person, as the person who is basically overseeing that and building that, the whole idea is that how more productive you can make it, right? And you won't know that until unless you have the data set to back it up. And I'm not talking about the data set of clicking 100 pictures and giving it to the client. I'm talking about the internal data set, how your battery is functioning, how efficient your specific machine is, how long it can fly. Do you need like multiple batteries to put it up in the air again, things like that. So this is all the data set that you as a PM or as a director or as an entrepreneur will need to understand in order to make sure that you can save cost and make the whole system more efficient. And I wrote this: we are entering this age of robotics. If you go anywhere, if you talk to any person working in robotics, this is sort of the line that sells you. We are entering the age of robotics. We're actually entering the age of robotics for past 10 years, right? They're already, unicorns, in US, which essentially created these robotic system. Aerobotics, $160 million. So we have been entering the age of robotics every now and then, but still we haven't been able to find a foothold, and focus and move ahead from that. The compliance is, I was a part of the whole drone delivery thing previously, and I know the compliance have been like moving nowhere. I think they've gone worse. We can definitely talk more about it. Maybe Dr. Ruchi will give like pointers on that. So I'll just move ahead though. So I talked about the key progress indicator in terms of what enterprises kind of need for your robotic system, from your robotic system, from your robotic application. These are all the 4 or 5 different things that they look at. But as soon as they combine these together, as soon as you put them within these companies' reaches, as soon as they basically start utilizing that, and this is how the interaction happens. All right. So what I've done is that I've basically divided the previous points into like 4 main points on which any company decides on whether they want to use drones or robots or whatever that is, and when they want to use it, or how they want to use it. So 4 different segments to it. I think the first right now currently is definitely the cost. So everyone wants that these systems should reduce cost. And what we sell right now is that, oh fine, these will be very, very cost effective 2 years down the line, once we actually working at a scale, once we are actually doing about 10,000 deliveries a year. And this 10,000 deliveries a year was my statement when I was actually creating this delivery network. Because according to my calculation, this is what you will require in order to basically bring the cost down, to compare with the e-van or the car that they're already using. So I'll talk more about that. But yeah, so limited to a single segment, single sector, single location, demography, it's not going to be beneficial for any of these enterprise operations. The third for me is the transparency, and that is something that is lacking right now. So all the 4 points that I actually you're seeing in transparency right now, and if you remember from previous slide I showed you, these are all the left points which are in violet, and no one is talking about them. So if you think about it, then right now in this industry, in the robotics industry, in the outdoor robots, there is no transparency whatsoever currently. Definitely some scalability. Then there's the whole topic about security. No one cares about privacy, and not at this stage. but this is where the world will go. And if you want to build something that is very very scalable, not limited to geographies, you will need to take care of the security aspect, even if you are not into like defense. I know as soon as someone says security, everyone start thinking about how these drones and stuff are being used by police and the defense, and definitely they will use it. No, even the basic B2B industries, drone deliveries, airlines. I'm working with a few airlines, and they are starting to do drone delivery. So even for these people, security is going to be very, very crucial. And this kind of relates back to the client, because you as a client want to feel very, very secure in terms of whatever you are planning to assign to these companies, whatever specific application you want these companies to do. You want any of this, payload delivery, mobility, they're flying you, or even just videography. You want that to be very, very secure. So that is how I think this happens. And I love to talk more about it. I wanted this to be like more of an interactive kind of a thing where we all talk about this on the slide, but I'll maybe get back to it once I wrap this up, and we can all talk about this, give feedback, your own understanding about what you think can actually be changed in this. So yeah, so for me, the tech stack that will actually enable each of these points. So let's start from transparency itself. So what I believe is that there will be a need where you will be able to basically track every single thing that is happening. So who is flying these systems, who is operating these systems, where they are operating from, what is the speed, altitude, flight time, path planning, all of that. Very, 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 very real time. That is something that needs to be there. The second thing in terms of transparency is the analysis of whatever is happening on ground right now, right away. And this might not look lucrative to you, but as a company executive who wants to see all of their assets in real time, to be very, very sure, this is something that I'll precisely choose to go ahead with. And you can even take the example right now. There are so many companies which are basically providing truck fleet a management solution, or Uber, let's say. The whole point of Uber is transparency. You click the button, you get who is going to be driving you, where he is coming from, or where you will be going, or where are you right now. So if you think the majority of the market, then Uber was basically in the market of assetless mobility, right? And the whole MVP was the transparency aspect of the thing. And now you think about the whole robotic side, where essentially robots are technology is so easy to integrate, every data is essentially full flowing inside, there's no human involved, and still we don't have the capability to basically track these systems all across the globe. We are limited. Many different reasons of the limit for this limit, but that's a drawback. And yeah, same goes for the analysis. Moving toward the security, then this is very easy. I think everyone will be able to comprehend. So you're generating data. You want it to be secure. You're basically configuring your firmware. You're changing things inside the robots. You don't want your car to crash. You don't want your drone to crash. You want that to be completely secure. Simulate. So before you actually go ahead, and do a specific mission, whatever it is, you want your system to be very, very sure about how you're going to be doing things. So currently, considering we do things very, very manually, so simulation happens, like the way that we perceive simulation is something where we actually see things happening beforehand it happens. But eventually the simulation will be very, very much like AI or algorithm, which will run very, very simply and very, very fast to basically show you this is sort of the path or the way that this thing should take. And this is something that we're currently working on. Just to give you an example, so we're working for a company which is looking to do ship to shore delivery. So they're using a drone which will be taking something and dropping it to a ship. Now, it appears very, very easy, because we think, oh, this is all water, you just have to fly over the water. But what we don't understand is that there will be like ships coming in in between the path. So now what you essentially want to do is that you want to automate the whole path planning in real time, or even before the drone flies up. You don't want a person to basically go and dropping in like pings and all of that to do it. It will be like the least efficient way to actually automate any unmanned robotic system. So what you essentially would want, an algorithm that basically keeps on running and provides you the final path automatically, and tell the drone or the robot or the ship to basically just move around like that. So this is essentially, and you want it to be done very, very securely, because any small like problem with that, and you're all done. And for a company, for a bigger company, this will be sort of a very, very crucial thing to do. And that is why I basically want you guys to basically think about these very, very small niche things that can only be understood when you actually go in the on the ground and talk to these different people. I hope that I'm not boring you guys. I'll move towards scalability of things now. So every time we hear a startup, we thought about how scalable the idea is, right? And it's essentially that, right? Because this is essentially a workflow or an operation or a job that you need to do, and you need to do it. You need to execute it again and again. You need your systems to adapt to the dynamic changes, which kind of happens every single time. And then you have to basically maintain these systems. You have 10 different drones. One got crashed, or something wrong happened with that, it cannot fly, and now you just have 9. Are you sure that you actually plan to do that? Can your whole operation happen with having just 9 drones? Have you even thought about it? Do you have like one drone in extra? But if you have that one drone extra, would it add to your cost? If it add to your cost, have you actually figured out how the whole operation will happen? So this becomes a very vicious circle. So scalability is not just about oh, we'll keep on adding like 2 more drones, and it will be very, very easy. We'll have like more land, we'll have like more stations, we'll have like more hubs where they can hop in and hop off. But it's more like can you actually do that without even thinking about it? And that is essentially the whole motto of being autonomous, is, right? And for me, the tech stack that needs to be involved to keep any of these robotic systems very, very scalable includes if you can actually plan them autonomously, if you can maintain them autonomously, the data flow automatically, and can you organize them very automatically, without even thinking about without a human telling you X Tesla going where, and Y air taxi going where. It should automatically basically make sure that things happen. And then you don't have to worry about adding these systems. You add one more system, the data in itself will calculate and calibrate and tell you precisely that not just one system, you actually need 2 more if you want to basically scale at the specific rate, which is something that you don't have right now. There's nothing like this right now. So the last point again, which was the first when I started, is the cost. From what I understand, I don't think I need to tell you what the cost is. So what I'll say is that the majority of the cost, and where I think the tech stack can actually help, is in the operate part. Like I said, very easy. Not just very easy, actually, the least. I'll tell you. Currently, we are working on a system where you will be able to actually manage and operate about 255 of these robotic systems simultaneously through a single computational device. So me, just a single person, will be able to control and command 255 of these robots. Eventually, this is something that we are working on. So if I mellow this down, so currently we have the capability to allow you the control and command up to 6 of these robotic systems simultaneously through a single machine, right? So this is what essentially I mean when I say operate. I definitely know that there won't be any scenario, where we just, remove the human altogether. What we essentially want is that we want to reduce the number of humans that interact with this whole autonomous flow. And we want these humans to basically supervise, right? Not give like specific feedback. I'll rather want that human to basically supervise and take decisions. I think this would be like the most optimum way. I think even in the next 5 years, if we can actually reach that, that would be like the most optimum unmanned robotic service that anyone could have come up with, right? Then there's this whole point of computing, the whole computational cost. You send things in the cloud, you store them, you do all of that. So how you can actually bring them down by automating and creating sort of a flow where the data flow automatically, and you don't have to put in like too much computational power all along. Then there's the part of storing. Everyone knows storing costs money, and how you can actually reduce that, right? Because so much data is already being generated. Do you always need the data to be analyzed? Do you need every single data to be analyzed? Do you need every single sensor's data to be analyzed? If you don't, then you have to basically create some kind of a system which can automatically detect what needs to be preserved, what doesn't need to be preserved, what is something that you can actually extrapolate, what is something that you cannot. How can you actually analyze these things? And these are all the things that where you will be actually able to reduce the cost. And the last thing is managing. Essentially, it's all about managing. So how productively, how cost effectively you can actually manage these things. And these are not just words. These are all tech stacks. These are all technology innovation that are there, that needs to happen within these words, to essentially build a very robust backend infrastructure that can then support anything in terms of unmanned mobile robotic system out there. Yeah, so let's move to the next one, and I think Dr. Ruchi has already have already seen this a year down the line, maybe back. Uh, the thing was, this whole a plan or a case study was something that we did when we were basically creating our own drone delivery network. We took Andaman Nicobar because this was sort of the area which was the most effective. If we actually use drones, there's a 300 kilometer, 320 kilometer to be precise, a road that leads from Shamnagar to the Hemba Sunset Point, which are like the starting and the end point of Andaman Nicobar. And then we realized, that there are about 4 lakh people that live over there. Every year, around like 4 lakh more people visit. So it's all around like 8 lakh people that you can actually directly connect with these drone delivery networks. And the idea is that like the tourists already have the paying capability, to utilize these drone delivery services. We took the part and the assumption that we'll basically set up a station, every, let's say, 6.3 kilometer, mark. A single drone will be able to basically move around, or can move around about 100 kilometers. And doing that, we come up with a very a comparative number crunching that we could do at the time, and people are continuously doing that. I mean, this is the only thing people are currently are worried about. They're not worried about creating these systems or implementing them. They're more worried about how numerically we can kind of compare the existing systems, and and the ones that we want to create. But the problem is that every single person who is doing that kind of is more biased towards bringing drones out, bringing these robots out. And that's why we basically do some very, very typical errors while creating these comparative system, which I personally also did. And I realized that afterwards, 1 year after, now that I'm sitting with you guys, I realized I did a lot of blunder. We compared events to drones. We realized we just require like one van per hospital, whereas you'll require about 2.5 drones per hospital. So you'll just need like 4 vans if you're taking just like one area, this 24 kilometer area. And drones, you require 10, then you require just 4 couriers, 2 drone operators. Events will take 42 minutes. Okay, but you know what, we can actually do that in 15 minutes. So this was like the MVP. We can actually do that in 15 minutes. Okay, fine. So how much per delivery cost? Someone will ask, and you will be like, oh, fine. So it's $1, $1.04 to be precise. And what does the event cost? And you would like $5.19. And suddenly, everyone will be like, oh, fine. Oh, so drones actually cost less. So why's not everyone basically going towards the drone side? What is that people are missing, or I'm omitting from this? And is this a correct comparison? So to be honest, it is not. It is the most best comparison that I could have ever done. And I'm happy to basically tell you that straight on with a straight face. The thing is that this is not at all optimized, and we haven't taken into account so many things that happen in the back end, because the event doesn't have like only these things. And if we compare like the company that is running an event and the company which are actually going to be running this drone delivery sector, it's going to be very, very different. The event will have like humans and humans and humans involved, and if the drone company is going to be having just humans doing that specific work, doesn't cut the cake. Secondly, if we take into the consideration the amount of payload that even will be carrying, that is going to be humongous. All right, a drone like our drone could have carried like 5 kgs, then this event would have carried about 100. Now you see where the price will completely differentiate. Now someone will come and they will say that, okay, fine, but what about like a very specific use case, very, very specific use case where you will require blood just in 15 minutes, and you don't care about carrying 100 kgs, you just care about carrying 500 grams of that blood unit within that 15 region time. And I'll say yes, that is precisely the use case that you have right now, right away, that you can actually implement. But then the problem is how many? What's the frequency? Will you be able to get the 10,000 flights right away right now? And that was the moment that we as a company realized, because Dr. Ruchi knows us, for I think about 1.5, 2 years. I was back in Singapore, and we were so focused on creating a drone delivery network. And these are all the data that we would put in. But as soon as we realized that, this is sort of the missing, like the plug, and the whole number game will shift as soon as you move towards the automation part that happens on the back end. Nothing to do with drone, right? Nothing to do with the drone's capability, just the back end part. How systems are going to be dealing, how we will be actually reducing the cost with, removing the humans, making them as least as possible. And that would be the time where the real value will come into place. And if I tell you the real value, and I told you that a one person, like with the tech that we're working on, like the one person will be able to, let's say, control 6 drones, and I do the maths again, then for me right now, just to do these deliveries, you will just require point 0.4 operator to do this. I know the point 0.4 operator doesn't sound correct, but essentially this is what you will actually need. So if we backtrace it and even extrapolate the whole data, then it essentially comes down to whatever calculation that we did at that specific point of time, we could have actually reduced the cost 60%, just by removing that backend infrastructure that we would have required in terms of humans, towards a more autonomous way, towards everything being handled automatically, towards everything being handled through these algos and through these workflows in itself, right? And I think that is when this specific industry, this specific robotic segment will flourish, when these manufacturers and these operators will be able to basically just really autonomously and automatically be able to operate these things. And I just wanted to like bring this, the drone delivery part, because I've already worked on it, and I've learned from it. And I guess a lot of people, I think the previous session was of cargo delivery. I think a lot of learning must have happened already, considering Village Reach has worked tremendously in this. And after this, if anyone would want to contradict or add on to this, or provide me some better suggestions or answers, I love to hear that. So I'll just move from there on, like the heavy duty drone delivery aspect. And I'll tell you that the whole thing that we're talking about, the whole thing about like truly unmanned, this is agnostic. This is agnostic of any specific robotic system. This is agnostic of any specific industry. This is agnostic, and this is an agnostic need for every single of these robotic system out there, right? So if a company comes up, if we comes up and say, we are specifically going to be focusing on a heavy duty bigger drones, or bigger robotic system, self-driving cars and stuff like that, and you say, hey, I just want to very specifically just create something very, very similar to solar panel cleaning robots, then I'll say yes, it will definitely work with these systems as well. And we have kind of validated this assumption. So we have spoken to all the different companies doing very, very weird jobs, autonomous lawnmowers, solar panel cleaning robots in itself, robots that basically clean water tankers. These things are very, very required in all of that. So if you guys want to go ahead and build something for your own, specific to very niche robotic segment, then I'll say that you can still go ahead and still do that. Just do one thing: first validate, what precisely the other person wants in terms of workflow, and then you'll be able to basically do that. Like I said, you can actually do that in logistics, mobility, healthcare, infrastructure, public safety, energy, mining, quarrying, any of these robotic systems, that are actually being integrated with these systems. You can take these points, build workflows, integrate them all, integrate in such a way that robots can actually communicate and connect with them, and you're good to go. So after all of that, I'll come on to what we are doing, and what our solution is after learning all of this, these problems, and all the heavy duty tasks, and talking to all these different people, understanding our mistake, how we come up with a solution, and what exactly we are essentially doing. So we are placing ourselves as an AWS or unmanned robotic operation. We know AWS, right? Any developer out there, you do, like, you create your stuff, you create a website, you create your web apps, then you go to AWS, you put things over there. So this more like plug and play, though much more skill and much more understanding needs to be there with all the DevOps. But the idea is that once you have the prototype, once you have the product, you can basically go to AWS and it will be live. People will be able to connect with it, integrate with it. People will be able to basically take it forward, and all of that. So this is what we mean, when we say that we want to be the AWS or unmanned robotic operations out there. In a nutshell, we are basically creating an AI-enabled universal architecture, which will allow any of these unmanned robotic systems out there to directly plug and start delivering services. So any kind of service that is agriculture or whatever, you can see that from these different kind of pictures. Previously, we are just drones. Now we have understood that the whole concept basically goes beyond that. And if we are able to basically create a tech stack that will be able to support all of them, then this is what we would do. What we do is that we basically enable these robotic manufacturers and the service providers by reducing the control errors, unauthorized access, and mechanical failures that can happen with their hardware systems. We enable these robots to dynamically adapt to the changing environment, so you can use them in different fields, different works, different ecosystems, and all of that. We manage that. We provide you the flexibility to implement them, execute them, extend and reuse them. So this again creates a complete circle, right? So whatever you did at a specific point of time, we record all of that. We use that record. Further, you want to go ahead and do a very similar thing. You don't have to basically come again and plan everything, do everything, think about it again. No, we already have the data stored for you. We'll basically take it from there on. We'll create a complete circle. We don't want you to basically do any kind of work now. You just come with a hardware delivery system. If I give you an example, an analogy, we are kind of want to be an Uber, where you have got a taxi and you have got a driver. He can directly plug in Uber. He'll get the clients. He'll be able to do everything he wants to do. Essentially, that this is what we are doing. And I told you about the flexibility thing. So again, the flexibility means is that we want you to take any hardware system. We want you to opt for any robotic system out there, and we just want you to plug into our system and and take it forward. Nothing more needed, right? So this is essentially what it is. Then we manage the system reliability. So like I said, as the number increase, the reliability keeps on falling down. So this is also our core focus, where we allow you that that interfacing and that analytics, that irrespective of how many vehicles, how many systems, how many different ecosystems, how many different teams you add, we make sure that your complete system or complete fleet is managed. Everything is essentially managed, and there is no problem in that. And the last part is workload distribution and compliance. We want to be very, very sure that you understand that if you have two different vehicles and they look completely alike, then we want you to be completely sure that we'll be able to tell which specific system did what, or which is working more or less, or which is doing what, so that there's complete straightforward transparency in terms of that. And as a user, as an operator, you can basically again manage it better, right? And while we do all of that, there's no need to for a human to basically sit down and and put data in and do all of that. We don't want that. As soon as you plug your system in, we basically directly stream all of the data, and we automatically generate all of these data segments, all of these data streams, all of these different segments, management and stuff. We don't want that. The first system is set, all good to go. And the last part is compliance, which is something that we're already working, but this won't be a huge problem for us. We're already integrating for drones the UTMs directly within our systems, and as you move forward, insurance and everything will be able to basically integrate all of that. So this is sort of a roadmap, and where the whole product is going to be. But the idea was to basically show you that where we came from, what actually we analyze, and how we're solving that, and also allow you to basically develop on top of it, if you want to. And the whole idea is that we want you guys, the developers, the customers, the operators, to focus on whatever customer that you have, whatever niche that you try to basically figure out, and not wasting time and resources on undifferentiated heavy lifting. And this is precisely what I talked about in the second or the third slide when I said undifferentiated heavy lifting. This is something that every single company will need to reinvent as a wheel if there is no sort of a backend infrastructure which will actually support that. So every single drone company, robotics company, rover company, self-driving car company, unmanned truck company, they all will need to bring this in their own systems in the near future, definitely, if there's nothing like this. So just to give you more understanding the whole take and how we are integrating these systems, as we basically are working on sort of a hybrid stack model. we have understood that putting everything up in the cloud is not a solution, at least not now, where there are so many applications and so many areas which are not going to be having great internet. So the way that we have basically built it is something where we connect the robot directly to sort of a channel or a command and control system, which essentially is not dependent on the internet. And then you can do like command and control and navigate and do all of that, all the different kind of robots directly through that. And then it dispatch all the parameters in terms of the pilot data, the flight logs, and everything up in the cloud. And then we segregate it into how we manage the orders and how we bring these robots in the workflow of the client. How we bring the order and the client and the robots onto a single platform, right? So you ordered a blood packet. How I can basically assign this blood to drone X, and all of that. So that specific workflow needs to happen very, very autonomously, automatically, and this is essentially what we do. We take care of your maintenance part. So we automatically calculate your hardware, software, electronics lifecycle. When we realize that the robot is already worked that much, we ping you, we tell you, and in the near future, once we have accumulated all the data, we'll actually be able to provide you predictive maintenance analytics, which means is that you don't even need to like worry about these things. Once a while a pop-up will come and they'll say that, okay, fine, your maintenance is due, you need to basically maintenance after this, your sensor is basically not working fine and stuff like that, and only then you will need to basically just move around and do all of those things. And autonomous systems, they require this pre-flight and post-flight analysis and things, much like airplanes. So we are also taking care of that, where we automate the whole pre-flight and post-flight checklist and stuff like that, where a single human can basically just click a few things and you're good to go. And then the other part is remote supervision. So if I ask you, you have a company, you are the CEO of a company, or let's say the manager of a company, and hundreds of drones, let's not even talk 100, let's just talk 10 drones are flying all across India, and you want to understand precisely what is happening with all of your fleets. There is no way right now for you to basically know that, and essentially this is what we mean by remote supervision. So what we have done is that you can fly any of your drones, any of your assets all on the globe, and we'll be able to show you irrespective of where you are, wherever you are, through the system. And then we are building a backend intelligence stack, which will essentially utilize all the data that we are capturing. And when I say data capturing, I'm not we are not capturing anything that deals with your client, like the end client, right? We are only capturing the vehicle data, right? So that has nothing to do with the privacy. So we make sure of it, and then we then we utilize that data to further provide you the suggestions. So the idea, so if you think about the color coding again, I've used it again. So what I've tried to show here is that, like, all of these different robotic systems, these are kind of tools, all right? These are kind of a hammer that you have, right? The hammer could be shiny, the hammer could be really great, it could be have made from a meteoritic iron. It could be amazingly well, right? Until unless a fine chap is going to be using that to basically put it over a nail and do that, the tool itself won't do much, right? And if if the person who's basically using that tool, let's say, is not capable enough to use it, then there won't be that efficiency or the optimization that needs to be there. So the way that we have basically divided the whole thing is that we feel that these robotic systems are tools, and these are not solutions. These are just technological tools which can be utilized to further provide solutions. And then we are basically trying to create this, the purple box, the operation part, as in that chap who is who is well enough to basically utilize these tools to further provide the output, the application, third party integration, the final conclusion, the tangible result out of it. And then we are using this command and control, which is a very simple word, but we are essentially using that to basically create a channel between this tool and this human. So that engagement is something that we are taking care of that, and we create a hybrid stack which is not dependent on internet, but takes everything, like every capability of the cloud within itself, hence creating this complete infrastructure and architecture, which we are really proud of. And maybe in the near future we'll hope to see where this leads to. So just quickly summing up and talking, just give you a sort of overview about the product itself. Like I said, we're completely agnostic, supports all different autonomous robotic systems. So if you have built something, you want to test something, we're also like providing direct integration even with like smallest chipsets. So we are working on providing direct integration with the Arduino boards. So let's say down the line you see, hey, Arduino has basically evolved much, and you would want to basically build some robo or anything directly on top of the Arduino. You don't want Pixar or any other autopilot. You can basically build, doesn't it's a mini computer or Raspberry Pi. You just want to plug it in and move ahead. These are all the kind of integration that we have in mind in the coming future. So we want to democratize these robotic system as much as we can, which something open source has already done. So we want to, so open source is basically democratize how you build these systems. We're here to democratize how you use these systems. So I think this would be like the perfect analogy for me to give to you guys to understand precisely where we fit in the whole value chain. And yeah, to sum it up, we basically bring all the control, command, remote supervision, maintenance, management, analytics, tools down to a single platform. So that's it. You basically plug your system in, and then you do whatever service that you want to do with it. Our current focus right now is that we basically are providing ready-to-use solution for anything that is remotely controlled in terms of drones, and we manage your enterprise drone operations. So we can do agriculture spraying, remote inspection, BVLOS operations. But something that we are very very enthusiastic and excited about, because we are coming from the side, is to basically manage air delivery systems. And we are currently working with a few companies, and we really hope that we are able to basically bring that truly unmanned sense. It definitely is not going to be truly, not in the another 5 years, 10 years or so. But yes, the maximum we can actually make it unmanned. So yeah, so for us, the value proposition, or any of the main value proposition of truly unmanned, is basically we reduce the cost, we optimize the use of resources, and we provide real-time feedback to all the humans that are basically involved with that, because there will definitely be humans involved. And while we do that, we essentially, even without doing anything else, we essentially streamline the operations, we enhance the security, provide you higher scalability, the visibility part, the traceability part, we add on to that. And if we accumulate that, then it automatically leads to a higher productivity, right, of your complete robotic as well as human workforce. So the complete company, complete organization basically works on the highest productivity level as they can. To sum it up, and this is sort of, I believe, the last that I've got, the thing is that we believe that such a universal architecture has a very similar potential to revolutionize this unmanned robotic infrastructure in a very similar way to how and what AWS did to these developers in terms of the cloud computing part, right? So it's very easy. You just go ahead, you put in something, you write a code, and you're good to go. We want it to be as simple as that, maybe just single line of code. If you're going open source, then without code, no code system, where you can actually just plug your system and you can create real businesses out of it. So yeah, that is sort of my time and what I had in my mind. But I can definitely talk more, and with whatever questions and suggestions that you guys have. Thank you so much.
Thank you so much, Nishant, for sharing your ideas and your approach with us. This is truly amazing. And I
Yeah.
hope it kind of really revolutionizes the robotics industry as you visualize it, and the future comes closer to us. I'll take a moment to ask if anyone has anything to comment about, any questions, anything that you want to talk about, that you would like to share with us.
I think that was too much information for everyone.
Happens.
Yeah, no, definitely. And you know what, guys, I can talk anything, even if this is just a general question about just entrepreneurship, robotics, startups, anything. So I have the time and I can talk about it if you want.
Hello, hello.
Yeah.
Am I audible?
Yeah, absolutely. Go ahead.
Hello. So first of all, hi Nishant sir, and hello everyone.
You don't
So
need to call me sir, yeah. Just Nishant is good.
okay. So I will start. So my question is rather, thank you for your amazing session first of all, and it was very informative, and we got to learn a lot about all these entrepreneurship and drone industry and all. So I have a very basic question, and so I want to ask. So so once we have the idea or the product for our business, right? So and we can deliver our services, and how do we approach the stakeholders and convince them to invest in our business, and so actually make lucrative business out of it. And So the biggest challenge in the initial stages would be uh, the financial aspect and funding and to make the business stable. So how do we approach the stakeholders? Where do we start? So
Right, right. So that is actually a great question, and definitely, I mean, this is the first question that comes in mind when you actually want to start something, right? The problem is that people are not going to bet on you if they don't see your skin in the game, right?
right.
They need that confidence that you yourself are confident enough to basically do what you're saying that you are doing, right?
Okay.
So the least resistance path is that you basically do ahead and do the 5% of what you are saying, right? So
Yeah.
if you saw what I told you about in the whole session is that we're basically building this huge amazing network that will allow any of these robotic systems, amazing, that will do something 100 times better. But what we have done right now is something that does that 5 times better. All right. And if you
Yeah.
can actually do that with the least possible resources that you have already got, then I think you have the case to basically move ahead. Right? Uh,
Yeah.
Once you do that, stakeholders, and there are like many stakeholders. They are like investors, incubators, they are clients, they are customers, they are people who are going to be working for you. They're going to be people who are going to be providing you some product or some value or some integration or some, if you want to manufacture something, some product, right? So the idea is that if you can actually do 5% of that, please do that, and then reach out to the rest of these stakeholders, because then these people will have a better understanding of what you're thinking about and what you're saying, and also that you have a skin in the game, and this might make things easier for you, right? So I'll just say that take that 5%, like 5% doing and 100% sailing as a motto, right, and then move forward. The early you can actually get a client, the best. We suffered because we pivoted, and we suffered because we couldn't get a client for drone delivery. We did so many different partnerships. We did partnerships with hospitals like Fortis, Apollo, right? We didn't get a single paying customer who can actually pay for drone delivery, and that is why we basically essentially realized that this is not how it can be done, right? So yeah, so as the sooner you get someone to pay for your 5%, and he can pay like just 1% for that by 5%, right? Are you understanding what I'm saying? You don't have to basically sell fully and do everything fully. Just prove like smaller percentages of that journey, right, that you're going to do in the next 2 3 5 years, whatever there is, and so many things will change. But just sell, and the smaller you sell, the bigger it will be for you. So that's sort of my understanding about how you can basically take care of these different stakeholders and reach out to them. Because if you sell 1%, if you're successful 1%, it's not about 1%, it's just that you're successful enough, right? So anyone who is going to be interacting with you, you will be a success, right? And it will be much easier for you to basically further sell yourself. So that is how I see it. I think I've hopefully answered your question. If I'm not, please reiterate that.
Yeah, it almost that's the problem, right? So like country like India, it's so big country, and there are so many brilliant ideas, and people are coming with new ideas every day, but they don't know, the youths today don't know how to go to the next step, like how do we scale up from here and get actual investors. And so mostly are doing jobs, and they are taking the
Right.
secured path for their career. And but it takes a great risk to go to the startup and actually make something out of it. So how do we go to the next step? So where do we get that motivation from to leave everything and just go for that?
All right, so this is a really big question, Sushant. Motivation. You know what? If there is something that I'm going to say and that is going to be motivating you, uh, that would be the worst of the cases. All right, because we whosoever is going to be taking this path needs to be self motivated, like motivated from inside, because the whole world is going to be demotivating you, like every
Yeah,
single thing. So if I'm going to say something and that will motivate you, and then the other way some Rahul will say something else and that will demotivate you, that won't be the perfect time for you to basically start. As soon as you get that internal motivation that you think you have got something, you think you want to work on something very very specific, you think that you have things in line, and you yourself are confident enough, right? then
yeah,
then that's the perfect time. It's just you, who needs to be confident. And there's this saying that I tell people that as an entrepreneur and as a CEO, as the person who is going to be leading the team, you have to be con man. All right, and this is a very bad word to say, but you have to be con man. You have to con yourself that you're confident enough to do a specific thing. You have to con yourself that you're good enough to do a specific thing. You have to con yourself that you're better than you were previously. You have to con yourself that things are going to be better, from what they are right now. So you have to be a con man. You need to be self motivated, and you have to build 5%. And if you do that, I believe that could be a good sort of a recipe to move forward. But there's nothing I can do. There's nothing Elon Musk can say, which will do something very, very different than you would have done by yourself. So yeah, so that's sort of my answer.
Okay, thank you, Nishant. Thank you, Nishant.
No worries. Is there anything else, guys? Anyone? So are you, like, most of you all are students, is it? Can you just like show hands however you can?
This group is currently all students, I guess, except a couple of them who are already working. So Ananya is working, Sushant is working, I know. Azad, Bhumi, Mabisha, Indira are all students.
Got it. So specifically talking about the people who are working, so what specific fields are they? If I may know.
Yes, Bhumi. Indira, Bhumi, Azad. Azad is a student. Indira is a student. I think the hand raise is for student.
Oh, okay.
Yeah. Azad has a question. Yes, Azad.
Please go ahead.
He generally types. So.
All right. Yeah, I think there's something inside. Okay.
So most of the girls that we have in our class, they belong to girls in tech community or women in big data community.
Okay, that is great. That is great. So these are mostly students, right? So are they in colleges, schools? What exactly?
Engineering. Most of them are in engineering and either mechanical or aerospace or electrical, electronics. That's the kind of field.
Very nice. Very nice. Very nice.
Yeah.
Azad, are you typing something? I see. So I have a question, but.
Yes. Indira is a veterinarian, so she's a doctor.
That is surprising, actually. I'd love to know this story. How did you happen to come towards the drone side?
Indira, you want to talk about it? Unmute yourself. Yeah, but this batch is very shy, Nishant. They hardly talk.
Yeah, I mean, 5 years back, I was the same.
Yeah. So according to DGCA, manufacturers need to provide 360-degree collision avoidance. So how can I implement it in my drone if I am a manufacturer?
All right, so this is a very specific question. Even DJI haven't done that. Okay, so this is a very specific question, and this kind of echo what Sushant said, that India is a very stupid country. I'm really sorry to say that, but yes, things do happen like that. DGCA might have their own, conception and preconception regarding, how they want these autonomous systems to work in, our airspace. How they think, that they would be able to better assess or provide some certification back to these people. So this is very, very dependent. How you can do that is basically innovate, man. If DJI hasn't done that, figure out something that you can do. Put 4 cameras on all the sides. Figure out someone who can provide you that collision avoidance. This is all easy in these days, like OpenCV and stuff like that. The only thing I want to say is that let's not question what DGCA wants, because they know what they want, and we cannot do anything about that apart from just writing, talking, and giving them suggestions. What we can do is basically figure out something and bypass what they want from some sort of an innovation. Maybe just by a basic line, we support what they want, right? Or maybe this 360-degree collision, because I don't know. I'm not sure, because how much I know, most of the time these are very ambiguous, open-ended statements. You want a 360-degree collision avoidance system. What does that essentially means? Does anyone else has a 360-degree collision avoidance system? Can you actually prove something to be a 360-degree collision avoidance system with very, very basic features, very, very basic things, and then come get back to DJS and say, hey, I have already done that. This is 360-degree collision avoidance. Can I go ahead? Because they don't even know like what exactly this means. The collision avoidance is still such a big, short thing that apart from like the smaller things, slam and stuff system, there are companies which are basically getting like tens and millions of dollars just to make sure that there's this air awareness kind of a thing where the collision avoidance can actually happen. So yeah, I mean, these are all the things that we have to basically figure out by ourselves. How you can do that, maybe reach out back to me and we can definitely think more about it. One thing that I can tell you that is, currently we are supporting through the software that we already built about 6 video streams simultaneously from a single drone. So if you want that, I can definitely support you that, like put 6 cameras all around, take the feedback and run AI on top of it. This is something that we can definitely do right now, but there's no answer to this. Hopefully DGCA can maybe provide like better understanding and clarification what exactly it means by that. Because I mean, if you're flying at 100 kilometer per hour, how you're going to be doing this 360-degree collision avoidance things in real time on a very 1 lakh, 2 lakh, 3 lakh drone, which essentially the whole part is going to be that much. How you're actually going to be putting that mini computer on top of it and doing all of it. This is all stupid, but yeah, this is what it is. I'm sorry to say stupid 2 times.
Hey, hello. Am I audible?
Yes,
Yes, sir.
Indira.
Yes, I brought the microphone from my brother. He was in the job. Yes. Now, I got to know about the drones in development program from the girls in technical, where the Astadi has told me took this, then it will be very informative and helpful for your subject. In the past time, I took the session about the ArcGIS. It was really helpful for me. I don't know that these courses was all about the helping and social development. I thought that it was about coding or in the inner portion. But when I took the first session, that Dr. Ruchi Saxena is also a medical professional. So I am very interested about this course and I took this. But due to my exam and then I could not get time for the much more time. But also it is very interesting. I told this situation about this course about my senior or junior. They told they just not only took the session but also apply in the veterinary subject because it is very important for us for the mass communication for the service provider. One thing in our villages, I want to share a story. In the villages, one the cow what was the heated by an kukuri. It means like a how much it was that the cow has about the one full hand food in his stomach and no one care about them. That these things we can find about from the drone. It is very helpful for our subject and our subject. So I took interested in this subject. This is I hope you can understand.
No, absolutely, absolutely. It's so good to know about how you got here, and then you eventually figure out something that can very, very be helpful for you. So that is actually great, and that speaks a lot, Dr. Ruchi. With the kind of program that you're building and with all the different people that you're basically bringing on board. I think there's something for someone like everyone. So that is great.
Yeah. In the past session also I further take the more courses also there only the portion are not from this medical session medical students or the veterinary students only I get from the another session who took the all the courses like that and they all said how you encourage for this session how you do and what are the application for this and all access for me then it is very interesting for me also encouraging. Thank
So
you.
good to know. So good to know. Thank you so much. Great to hear that.
Thank you.
Anyone else want to share their story? Any question? I usually do give dumb answers. So if you have a very smart question, please go ahead. I'm all ears.
Indira, you'll be very happy in the third week of this course. Third week, yeah, we're already in the second week now. For the next few days, so there will be speakers who will be coming and talking to you about biodiversity and habitat monitoring and wildlife. So you'll be happy with that then.
Of course, ma'am.
Great.
And Dr. Ruchi, if I may ask you, question, I saw, I believe we have already done the session on cargo, right? I think Oliver did that from Village Reach. How was it? I mean, what was the core learning out of it? Because, as a drone delivery sort of background, I love to know, what he had to share about that. And if there's something you or, anyone else, other people might have, figured out something, I love to hear about that as well. That's
We'll
fine.
have a couple of more sessions on drone deliveries. Tomorrow we'll have Nepal
Okay.
talking about their drone delivery project. Then we would have some more sessions on BBLOS flights itself, the UTM and the command and control and operational difficulties as well. So we'll
Okay.
be talking a bit more on this in the next week itself.
Got it.
So tomorrow and next week, the first couple of days will be dedicated for that.
All
And
right.
Olivia had stressed upon the stakeholder engagement more,
Uh-huh.
like how complex it can get when you are talking to different stakeholders. How do you
Right.
bring them together? How do you actually make the project happen? So there's
Right.
less of drones, less of technology, more on the operational side of it.
Right, right, right. I believe this is where we come from, so I can definitely understand that. This is the hardest thing to do. Bringing humans on board is much harder than bringing drones on board. So yeah, that is what it is.
Absolutely, absolutely. So the goal of this course is to really make leaders.
Mhm.
And when you are leading a complex project like this, you really need to think 360 degrees. And that's the reason you're bringing people from all spheres so that they have as much exposure to technology as well as projects, both.
Absolutely.
And then they have a balanced approach when they are looking at the next big thing that they're trying to do with the technology. Not
Right.
just drones, but any technology for that matter.
Absolutely. Absolutely. Makes sense. Definitely. Definitely.
So
All
I
right.
guess nobody has a question.
No,
Nishant?
hello, Nishan. Hello, Nishan.
Yeah. Hi.
Yes, we have a question from Ananya.
Hi, I have one question. That is there any drone delivery pilot project is currently working in India, running in India,
Uh,
other than Telangana, where state government has approved the
right.
vaccine delivery project?
Right. So none actually. Most like all the different stakeholders that want to do drone delivery are essentially involved with the Telangana government experimentation and project. So that is the only one from what I know of. Maybe Dr. Ruchi can tell, but yeah, I don't know anyone.
Like getting the permission from DGCA and other governments in India for delivery drones is very much difficult because of security reasons. So
See, sorry, go ahead. Sorry, I interrupted you. Please go ahead.
no, you can talk. So for me, what I have researched from my side, it is I think it is quite easy in Africa because that country is more underdeveloped, and their government is actually working on this and allowing along all the drone deliveries projects. But in India, are we doing something in this sector?
Yeah, great question actually, Ananya. So the thing is that we definitely are lacking from the rest of the world. Europe Horizon 2020 is actually pushing so much into air mobility and drone delivery that we cannot even comprehend. People are getting, millions and millions of dollars of just grants to as a consortium to basically do these deliveries and do these air taxis and stuff like that. And India hasn't even started. From what I know, like even this Telangana experimentation is essentially an experimentation which will do about like 2-3 specific tests, and based on that, they basically figure out what more they can essentially do in the near future. Whereas if you compare that with like other areas, geographies, and countries, I know, and I'm involved with drone deliveries happening in Malaysia. I know drone deliveries happening in Kenya. So Africa is definitely a huge spot. Definitely regulations are way less. Governments are easier to get to and to mold according to what you need. If you have money, then it's again really easy. UNICEF is running a lot of USAID are running a lot of operations over there. So Malawi already has a drone corridor where you can actually go and test your systems. Lake, I think it's Wanadao, does a competition every single year where drone delivery companies will come in and actually deliver over the lake itself. Uh, uh, and Europe, the big like the billion-dollar company that are basically doing drone deliveries. One zipline, but they're already doing so much operation from past 6, 7, 8 years. But the main one right now is Mana Aerospace. If you want to have a look at it, it's an Ireland-based company. Started in with like in pandemic itself. They wanted to deliver food samples, but then they put it on to start delivering healthcare supplies. Bobby Healy, amazing guy, focus on supply chain, and now they're basically moving towards. They've already done about like $30 million in their funding, and specifically they are the only company which are actually doing drone delivery in urban space at a commercial level globally. So this is what it is, and I don't see this happening in India anytime soon. Red Wing is definitely doing that. We and Red Wing definitely started at the same time, took different journeys. But yeah, Red Wing I think is the only front runner in India who is specifically focused on the whole drone delivery operation. And we have essentially pivoted. So this is what it is. And then there are other companies like Zomato and every other logistics provider. But I don't see it as a very focused drone delivery move, or rather than just a move where they can actually create some PR, understand how it can be done and stuff like that, and maybe whenever they want to do, then they can eventually do it because they will at least have that certification and understanding of how drone delivery loss can actually happen. So this is my perception, but yeah, Ruchi, if you have some better comment to it, I'll definitely love to hear that. Ananda, do you want to say something? Really sorry, you're saying something.
Oh, thank you. Thank you for your explanation. I got the answer, and I have one more question.
Yeah.
I just served on the Vyorius website. So there are two applications. One is operation manager and maintenance manager. So the maintenance manager is feasible with any kind of drone, not only with DJI. Like it will support in Indian made drone also in future.
Good question. So currently we are not even focused on DJI. So DJI small drones, until unless you're using a mattress, which I believe Nepal drone delivery uh, group used. So until you're using mattress and the enterprise level grade drones, we are not very much focused on that. Like I said, we are very much focused on enterprise. And yes, for the other part of the question, yes, we can essentially do that. For when you say Indian made drone, you essentially mean anything that is open source, until unless someone is working on very proprietary. So yes, any open source thing we can. It's just direct plug and play. You don't even need to do any integration. We don't even need to do any integration. You plug your drone in, and we'll provide you all the operation, management, maintenance, all of that directly out of the drone.
Okay. Thank you.
Thank you.
My comments about what India is doing is, I really personally believe this, that India is very unique in its political situation. So our priorities in terms of security are way different from any other country. And that's the reason we go slow, but we are going steady, and we are inching towards the final goal, but we are making it work, making it happen. So it's okay if we come like last in line, but then I'm sure we'll have the most robust systems in the whole world when
Right.
in terms of traceability, in terms of quality, in terms of safety, in terms of public security, in terms of robustness. So this is my belief. Again, I'm like looking into the future, but then let's keep the faith on our systems. Let's keep the faith on our technologies and our technologists, and also let's just keep the faith on our policymakers that they know what they're doing and they're doing it very well. So we could have done it much earlier, but then we chose not to. So there are reasons for it, right? And we
Right. No,
didn't just kind of we just kind of didn't cling to what the world was doing and sat in the rat race. We we decided to go slow. We decided to take few steps back. We decided to make our policies our way, and we are so what do you say? Um, we're so bullish about it that that's what it is. No changing it. So it's okay. Let's go with the flow and see what happens.
Absolutely, absolutely. And I think, like with all these policies, closed doors, and regulation essentially provides you the capability to understand, how you can basically move around that and, do something, that doesn't harm it, but essentially, makes the way for it. So yeah, definitely. And essentially this is also like what we are trying to do with all the rest of the risk, like decreasing the risk and the regulatory affairs and stuff like that. And again, figuring out what essentially we can do where we can actually work globally, but as well, doesn't fall under these legal regulations per se. So you can, there's so many different and there's so many things, so many pain problems that people haven't even figured out yet. All right. So this is not done, right? Drone delivery hasn't started, guys. It's not there. No one has the monopoly over it. It's not done. So it's all democratic right now. You come up with something, you come up with something amazing, and you rock the whole domain, and then you will have that. So yeah, so you still have time, which is I think the best thing and the good thing, because if you talk about like competitive, what is it? Like what's the moat around whatever you do. So I think in India the biggest moat would be whoever is going to be doing it over here, or whoever does it first, or whoever does it very securely will have like a huge playground to play around with. So this is also a great thing.
True. So slow but steady, I think we will win the race, and we have our own races to win. But what I also see in India over the last couple of years is that we have the roads till the last door in the last village, at the topmost corner of a hill.
Right.
That's something that we have made a progress on, which is I think way better than allowing drones to fly, because you now have a road corridor, and roads would double up to do a lot of more development than just deliver the medicines. So
Right.
they would bring everything to the doorstep, to the last primary health center. So when we talk about the last mile delivery, the last miles have been enabled in India because of the road network. So this is something very handsome which has already happened. And I believe, I don't know, at least till where I have traveled in most of the states, you have good roads, and may not be all of them may not be blacktop, but at least you have a road till the last
Right.
door. So that is something great. So you can still have motorcycles, and you can still have cycles, you can still have
Right.
people walking, but then you will have something. It might take more time, but at least you'll have stuff available.
True, true, true. And I think, every different geography, demography, anything, will have their own specific problem statement. It doesn't necessarily need to be, challenged or pushed or solved by the same thing that, anyone else around is solving. So that is also there. Maybe you won't need a drone delivery. Maybe you will need
Maybe.
autonomous driving system, moving all around the India. So these could
Absolutely.
definitely be all the different things, that we can see in near future. No one knows, but I just hope
Absolutely.
that we have some hand in that. So I look
We
forward
will,
to it.
we will. So we're already planning on it. We will have it. It will all happen. We'll
Good
all
to
have
know.
our roles to play. So thank you so much, Nishant, once again. Before we close the session for today, I thank you once again on behalf of everyone, and thank you, class, for being such a sport today and being around. I really hope you're still enjoying the course. And once again, Nishant, thank you for your generous sharing of your knowledge and
Thank you
experience.
so much.
I
Pleasure
really
all
hope to
mine.
see you more often.
Absolutely, absolutely. Love to do that. And I have too many things to even share. So I'll hope to speak with you very, very soon.
Thank you.
All right. Bye bye. Take care,
Bye
everyone.
bye.